Recording the results from a coin toss is a perfect example of measuring a discrete random variable. We'd like to toss a coin 10 times and record the number of heads, but the only simulator I could find tossed 10 coins at once, so we're going to do it a little different. We'll toss 10 coins 1 times each, and then we'll record the number of heads. In my first trial of this experiment, I tossed the coins and I got 3 heads. In the second trial, I tossed the coins and I got 2 heads. Let's record this in a table, the number of heads for each group of 10 coins tossed. I repeated the experiment many times so that we could have a big enough data set to see the results. I mentioned that this example was great for talking about discrete random variable, but what does that mean? Well, first, discrete means that the outcomes of the experiment that we're doing are numbers like 1, 2, 3, they're whole counting numbers. They're discrete numbers. They're not numbers like negatives or irrationals or repeating decimals. Random isn't the random that you use when you're talking about your friends doing something random. In this case, when we say random, we're talking about the outcomes of the experiment are random without any bias. And then lastly, we know that variable is a placeholder for values that are allowed to change. So altogether, the discrete random variable is something that measures the outcomes from an experiment in words. The notation that we use for discrete random variables are capital letters to describe what the discrete random variable is, and then lowercase letters to list off some of the values of that variable. So for this activity, the number of heads resulting from tossing a coin 10 times, that is our discrete random variable. We'll use an uppercase X and we'll describe it in words. Little x is the list of all the possible outcomes from the experiment. We could toss 10 coins and get 0 heads, or 1 head, or 2 head. We could get as many as 10 out of the 10 coins landing on heads. The lowercase x is reserved for listing off values of our discrete random variable, and you'll notice that the values are always listed out as discrete numbers. We have the outcomes of our multiple trials counted using tallies in our frequency table. Let's go ahead and count them all up. Notice that we didn't have any outcomes where there were no heads resulting from tossing 10 coins. We also had no results with just a single head, none with just 9 heads, and none with all 10 heads. So most of our results were ranged between 2 and 8. Actually, all of them ranged between 2 heads, or at the very most 8 heads in one trial. Thinking back to our frequency tables that we used earlier in the class, we know we can figure out the total number of trials just by adding up all of our frequencies, and we can see that there are 35 trials for this experiment. Knowing the total number of trials means that we can calculate relative frequency just by creating fractions where the frequency of any one outcome is copied into the numerator and the number of trials is copied into the denominator. Looking at these relative frequencies, we can see that the most common frequencies are happening around 4 and 5. And if we were to continue this experiment over and over and over, we would expect the results to become very close to being at 5, because we know that there's a 50-50 chance of getting heads, and so we're expecting about half of the coins to be heads in the long run. So this is about law of large numbers here. Any one outcome could have anywhere between 0 and 10 heads, but as we repeat the experiment more and more and more, we expect that frequency of the outcomes with 5 heads to increase more and more and more and stand out high above all the other outcomes. We know that as the trials increase and our empirical results get closer to our theoretical results, we can start to call the relative frequency a probability, meaning if we have enough trials in our experiment, the relative frequency is essentially the probability. This is the introduction to our probability distributions. So in this chapter we're looking at probability distribution functions for discrete random variables. We call the probability distribution function a PDF. So not the file type, but a probability distribution function.